Oh yeah, you're fine. Okay, Algebra 2, Section 4.7, Inverse Matrices and Systems. We've seen how you can write something, a system of two linear equations in standard form, but we are going to change this into a matrix format, or a matrix equation. So for instance, you see on screen here that we want to take the coefficients of the four variable terms right here. So the coefficients here are 1, 2, and you pick them off in the order that you see them, and then 3, 5. You don't change anything about it, you just pick them off the way you see them. The variables are x and y, and the constants are 5 and 14. Now, this will make sense to you because if you take this row times this column, that would be 1x plus 2y equals 5. Well, that's what that says right there. 1x plus 2y equals 5. So your coefficient matrix times your variable matrix equals your constant matrix. That is called a matrix equation. Matrix equation. Now, the coefficient matrix, we'll call that A. The variable matrix, we'll call that a matrix X. And the constant matrix, matrix B. We've done something like this when we talked about the matrices. We need to know how to solve this. You already know how to solve this. How do you get rid of multiplication? No, the answer is not division, because we know that there's no matrix division. We are going to left multiply by the inverse, right? Left multiply by the inverse. Now what happens over here with these two? Yes, they become the identity matrix. And we know that the identity matrix, remember the 1, 0, 0, 1 matrix, times any other matrix is still that matrix. Over here, this is the part we're interested in. Remember we talked about the really important side but boring, and yet this is the really interesting side because it's got your solutions. Well, so right now in your notes, I want you to do this same process. I want you to change this to a matrix system, and I want you to remember, so you're going to be filling in your coefficients, your variables equal to. Now make sure you move your constant matrix over, right? Because we know that you're going to be left multiplying by the inverse on both sides, and you've got to give yourself the room to do that in order to answer the question. So you'll do that in your notes, just like we did back when we talked about the matrices. The next thing I want you to do is I want you to write the system of equations as a matrix system for this particular system, but I don't want you to solve it because we haven't talked about 3x3s, and we'd have to use a computer or calculator for that, a graphing calculator for that anyway. So all I want you to do is I want you to change this to a matrix system, and yes, it's bigger than the 2x2 situation, so you'll have to take that into consideration when you do something similar to what you did in setting up the matrix equation, just like I did back here with the 2x2 case. Okay? So I have to do a little bit of work or a little bit of thinking, but it won't be too bad. Okay, another question for you to work on. A bead store has a sale on certain beads. I want you to find the price of each size of beads, of bead, and then I've given you this information. 2 large beads and 3 small beads cost $3.25. 3 large beads and 4 small beads cost $4.75. So you need to come up with 2 different equations, change it to a matrix system, all right? So use matrices to solve this. The last thing I need you to do is I need you to go to page 212 in your book and look at example 5. The coefficient matrix can answer a question. So just looking at this coefficient matrix, we can find the answer to a particular question. So I want you to look at example 5, and I want you to answer this. For what can you use it? What can you get out of, what information can you get out of the coefficient matrix? And I want you to tell me what you can find from that. And you'll find that on page 212 in example 5. Talk to you in class tomorrow.